Which of these two molecules has more valence electrons? The one on the left, the one on the right. And you might have noticed that the molecule on the right isn't neutral, it has a +2 charge. So wouldn't that mean that the +2 molecule simply has 2 less electrons than the other? After all, each electron has a -1 charge. Well, the answer is not necessarily, because we could have a molecule that's super positive but which still has more electrons than a neutral molecule. Therefore, unless the number of protons is the exact same across each molecule, we cannot compare the electron count simply by comparing the charges of the molecules. Not to mention, for this problem we care about valence electrons specifically as opposed to total electrons. So we'll have to take this into a different direction. There's actually two ways we can compare valence electrons, using the molecular formula or the stick and dot method. For this video, we'll use the molecular formula pathway, and at the end, I'll link a video on the screen and in the description to show you the stick and dot method. This molecule has a molecular formula of C2H4O, and this one is CH2O and F2+. This equation converts a molecular formula into the number of valence electrons using both multiplication and addition. Specifically, we take the number of each element, multiply by the group number, and we take all of these products and add them together. Carbon, for example, contributes 2 times 4 valence electrons. This is because there are 2 carbons in this molecule, as shown by the molecular formula, and carbons in group 4. So each individual carbon contributes 4 valence electrons. Therefore, 2 carbons contribute 8 to the molecule. So what about hydrogen and oxygen's valence electron contribution? We know that there's 4 H's and 1 O in this molecule because we look at the molecular formula, but what group number are they in? Well, again, we go to the periodic table and we see that hydrogen's in group 1 and oxygen is in group 6. Therefore, each hydrogen has 1 valence electron and each oxygen has 6. So taking into account how many of these elements in this molecule we have, hydrogen contributes 4, oxygen 6. Then we got to add them together to calculate the total for our molecule, and we get 18 valence electrons. So this molecule has 18 valence electrons, but what about the other one? Seems pretty straightforward. We'll just do it the same way, right? Well, no, because this molecule has a charge, and we must take that into account when calculating the valence electrons. Let's try it first as if it doesn't have a charge. Carbon would be 1 times 4 because it's in group 4 and there's 1 of them. There's 2 hydrogens times group 1, etc. So altogether, if we didn't have a charge, it would be 24 valence electrons. But we do have a charge, and to account for the charge, we take away an electron for each unit of positive charge. So because the neutral version has 24 valence electrons, if it has a positive charge of 2, we would simply have 2 less electrons. This is the equation that we would use for finding the number of valence electrons for a charged molecule. And mathematically speaking, we subtract the charge away, and 24 minus 2 equals 22. So it's clear that the charged molecule has more valence electrons. But there's also another way that you can find the valence electrons of a molecule. I call it the stick and dot method, and this video is on your screen.